All right, good morning, folks. Thanks for joining us today on today's webinar, which is all about an introduction to Fusion 360. So my name's Dave Wilkinson. I'm a technical specialist with Autodesk. I've been working with Autodesk products and such like for the last 10 years or so. Before that, I was a fitter turner actually by trade, and then managed a drawing office for a little while. So come from industry and decided to get into the software side of things. So thanks for joining. I'm going to kick off this morning with just what we're actually going to cover during today. So brief introduction around what Fusion 360 is, and then we're going to have a chat with James Cooper from Robo Challenge, who's with me here today, and then we're going to have a short technical demonstration with Fusion 360, which is just going to be basically a touch on most of the areas within the software to give you some idea of its capability. Okay, if there's particular areas that are of interest or anything that looks particularly useful for you, then by all means get in touch with us and we can explore that a bit further after the webinar. Just don't have time to get through everything today in a deep understanding. So to start with, a little bit about, well, not so much Fusion 360, but Autodesk as a whole. We have a message or an ethos through the company at the moment called the future of making things, and that whole ethos is based on what we're calling a product innovation platform. So that's not particularly about a piece of software, it's about a platform and having connected pieces of software. So different software solutions within the design space, within the making space, and within use space as well. So once the product's gone out the door and is actually being used. Now, the whole idea around that is that we have different solutions that can connect together and sort of not streamline, but make it a more intelligent, an intelligent solution, if you like, where we can feed data back into the design. So it's like a cyclic process. You'll see right at the centre there, there's an F, which looks very much like a Fusion logo, which indeed it is. That's not to say that's Fusion 360 at the centre. It isn't. It's just our branding, if you like, of the product innovation platform as a Fusion platform. Fusion, if you look it up, then you know it's a fusing of different things, and that's kind of what we're aiming at with the different pieces of solutions that we've got. So to talk a little bit more about that. Fusion 360 itself, or this platform, is really aimed at giving us an integrated product development platform where we're not just about doing 3D CAD, we're not just about doing particular tasks, we're more about doing as much as we can within that platform. So if we look at this slide here, something like, you know, generating form, traditionally 3D CAD, but also testing function to see whether things will work, so mechanisms and such like. Being able to fabricate, so we've got built-in CAM within Fusion 360 as well that allows us to machine things, and then managing that data as well. One of the key things with Fusion 360 is it's cloud-based, so being able to manage that in a useful way is particularly helpful. Talking about the cloud, I'm sure most people are aware of social media, certainly Twitter and Facebook. Go onto your accounts and look up Autodesk Fusion 360. You'll find us very easily. If you subscribe to those accounts, you'll see there's an awful lot of information coming through and being presented on a daily basis, almost hourly with some things actually. There's a massive movement out there of people that are using the software to do all manner of different things. Some really good snippets and case studies and such like that are coming through. That said, if we look at the product itself, it's used in a lot of different areas, but maker spaces it's used, you know, quite thoroughly. Startup businesses as well, and there's some reasons around that we'll discuss as the webinar goes on. But also it's a bit of a disruptor. So hopefully, as you'll see today, and as I'm sure James will testify, it's a slightly different take on 3D CAD. It's not the traditional route with how some of the older packages generally work, and it's not just about those small companies either, about those startups or makers and small environments. We have a number of industry leaders, large companies, who are actively looking at Fusion as an alternative way to do certain things. Fusion itself is actually a development really of what people have told us. So what you people, designers and engineers, have told us they're looking for, things that they want or problems that they're trying to solve. And probably two of the biggest areas for me that I come across on a day-to-day basis are around accessing the data anywhere. So when I say that, there's a couple of angles to that. But the first is being platform independent or OS independent, shall we say. So whether it's PC or Mac, Fusion will work on both. We have an app on tablets and smartphones as well. So we can access that data and look at it, modify it, so on and so forth. And also being able to connect teams together. And this is a big one. This is probably the most prevalent one that I've come across in industry. And this is all about talking, having multiple design teams, talking together, using the same data, collaborating, sharing that data, reviewing that data live. So that's all available. Again, Fusion is cloud-based, so everything that you're doing is uploaded to the cloud, and that you're able to invite people to share that data, review it, work on it if so required, so on and so forth. And that's really why we built Fusion 360. It's a different take on things and allows us to just approach things in a slightly different way, but with a cloud basis in mind, which is the way the world's going. So that's a brief overview of what Fusion 360 is about. I'm going to do a technical demonstration at the end, which will get into a lot more information. But before I do that, we just go through. We're going to look at, we're going to introduce you to James Cooper from Robo Challenge. James is in a very fortunate position of working on some incredibly cool projects for which he's using Fusion 364. So I'm going to hand over to James, or we're going to have a bit of a discussion around some of this. And over to you, James, if you'd...
Hello, David. So we're a creative engineering company, so we make all sorts of strange, odd things for big PR stunts and TV shows. So here we made the world's fastest jet-powered bicycle for the Gadget Show to break a Guinness World Record. In the middle here we've got some giant 5-foot-tall mechanical spiders that were designed for a toy company, and these 100-kilo spiders could battle each other. So that was a stressful but good fun job. And then a couple of our more high-profile projects is obviously Robot Wars. We were the team that designed and created the brand new house robots for the show. And Mack, who we've just finished for Xbox to promote the launch of their new game. They're all incredibly different types of projects which required very different design angles to them. And so it was great to use Fusion and the capabilities that Fusion has to be able to tackle all these different problems, from having to simulate specific movements for, say, the spider. It had to move in a very particular way, to being able to design things and 3D print them very quickly, which we had to do with Mack. So it was great to be able to tackle lots of very different problems and very different sorts of design strategies, but using the same software.
Okay, perfect. Sounds like I'm quite envious actually, James, because some of this stuff is just, I think, is really cool, particularly the Robot Wars stuff, which was...
It was a few sleepless nights, and we only had 2 months to design and create all 4 of the new house robots, which
is quite tight, I imagine.
It's terrifying.
Okay, so that's really cool. If we take one of those, so the Mack from Recall that you did for Xbox, can you tell us a little bit more about what were some of the challenges and what you went through with that?
Well, the first thing was understanding the scale and the detail. So Xbox really wanted to promote the game, but there's no point in creating it unless it was exactly like Mack out of the game. So it had to be super high detailed, which meant that we really needed to be able to 3D print all the components. But it not only needed to look good, but it had to move in the same way that Mack moved. So there were 2 very different elements. There was an internal skeleton which had to fit these little motors in, gearboxes that we had to design. They're all custom made in Fusion. And then there's this whole 3D printed body and heads and all these animatronic bits that had to be 3D printed. So there were 2 very separate sides to the design for Mack.
Okay. Cool. If anybody's not seen this, I've seen the real thing at James's place in Birmingham, which is really cool. If you go online and do a quick search for Recall Mack, there's some videos of it sort of doing some kind of cool stuff, and it's quite funky, which is pretty cool. So yeah, that's one project, I guess. The main one that drew Robo Challenge to my attention was really Robot Wars, because I watched right from back in the early days, the first series and such like. I was a big fan of the new series that came out. So yeah, it was really cool to actually meet some of the house robots. Amazing how big they are.
A bit terrifying, aren't they?
They are a bit terrifying, yeah. You just don't get the scale on the TV at all.
Exactly. I mean, that's what inspired us originally to create Robo Challenge, was watching the original series on TV. And for us, this was the dream job. So for the BBC to ask us to design and create the new iconic monsters for the show was incredible. And so we went around it in quite an interesting way, in that we split our team into 3 separate groups. So it was a bit of competitiveness between us. We'd all go off and design and create them separately, and then come back together to see which one was the best one. So I designed Dead Metal, so hopefully that's people's favourite.
Cool.
They're all very different machines, which was very interesting. They had very different problems for each of them, from having to withstand extreme pressures like in Matilda, to having complex sort of mechanisms and the way they move for Dead Metal, which we have a look at in a minute.
Okay, cool, excellent. So I guess if that's all really cool stuff. But if we relate that specifically with Fusion 360, because that was used predominantly in the creation of all of this this stuff. So it's sort of a key question, I guess, is how has Fusion 360 been able to help you plan the new designs of the robots that work in the way that you needed them to work and such?
Well, because we had such a tight time scale, it was really important that we had more than one person working on the job. We couldn't have done it in time if I was solely on the CAD design. So we had, in this top left picture, you can see like the motor gearbox is covered by the wheel there. So we had some guys working on that, and at the same time I could start working on the circular saw mechanism. Okay. And so that was really important, that we could all get onto the project and start designing the bits and then bring that all together. Yeah. But also, it's obviously with Fusion we can simulate the movements, and we can see here the circular saw actually retracts into the body to keep it safe, and it makes Dead Metal's eyes look at the opponent. But when it comes forward, it sort of tilts the disc into the opponent so we can give them a good old sawing. But that's quite an interesting mechanism, and it was really important to be able to simulate that, to go, okay, is that quite right? Okay, can we tweak it? Yeah. We could then go manufacture some parts, give it a test. If it was no good, we could then modify them and just cut out some new parts then. So that was really important, the speed of the design and the efficiency of being able to
iterate through that and make changes on the fly, if you like. Excellent. Yep. Cool. Okay. James has very kindly given us some data for Dead Metal as well, so we'll perhaps have a look at that later on for real, which will be pretty cool. So another question then, I guess it really touches or picks up from what you've just said, being able to be reactive and agile to quickly address those manufacturing issues. Are there any particular examples that spring to mind with that, with either Dead Metal or any of the robots really?
Well, to be honest, all of them were the same, in that we had such a tight time scale to design and create them, and they couldn't fail on the show. It would have been no good having Dead Metal come out and just fail. So it was so important that you can see these gearboxes on the right here. They had quite a few modifications, because we would design them, go, yep, that looks about right, let's cut those out quickly, we'll produce them, we'll give them a test, and we'd find little failures or little things that we think, that needs a bit of tweaking, it's getting a bit too much stress or something. Okay. So then somebody else could be quickly redesigning those and getting those out very quickly. Yeah. On the left here you can see like the internal mechanism. You've got the pneumatic ram on the back there, and that pushes that head forward. So it was really important to be able to get that movement correct. The same with the jaws, get that movement correct, be able to simulate it to see if it is the right movement for the job, to make sure that the power required for that cylinder wasn't going to bend and twist the metal. That was really important, obviously. But then obviously also be able to make changes very quickly on the fly and to make it a very efficient process so we could get them finished in time.
Fantastic. And just one question with that, actually, because I know that more recently Fusion has a suite of simulation tools in there now for doing stress analysis and such like. I'm guessing that wasn't something that you used on this particular
Not
process.
on this particular one, but you can be pretty sure we'll be
using
it.
Be using it, yeah.
Yes,
now that it's in there, absolutely. Cool. Excellent. Okay. And then, again, really, you've touched on that. But I know from when we were speaking previously that there's some like little cool stories around certainly Matilda's spikes and the jaws of dead metal on manufacturing output directly from Fusion.
So obviously with dead metal's jaws, they're made from plate steel. And they're quite a crucial shape because they have to open and close in a very particular way to draw the opponents into dead metal saw.
You really are vicious, aren't you?
Yeah, well, this is our job. So we had to be able to very quickly turn things around. So the great thing with it was on dead metal that we could design the jaw shape and just save them as DXFs straight away and plasma cut them, so I could modify the jaws and literally in 10 minutes time have the cut part there in my hands and go, yeah, this looks good, this does. Underneath we can see Matilda's spikes there. So Matilda's got loads of spikes all over her body and all over the crest of the head. Am
I giving the game away a little bit if I say when I touched them they were kind of foam and wobbly, not like really hard and spiky?
So, yeah, they're made out of foam, but they had to be a really organic shape. So the original ones would have been made from clay first, which obviously takes a long time to sculpt and to get them right and to make molds of them. Here we can see the array of Matilda's horns that's just got 3D printed, so we could I literally made the first one on the left there, and then for all the others I just spent about 30 seconds just tweaking that in the in Fusion, so then we could just 3D print the lot and make molds of them so we can then produce them quickly, and that really is so important to us as a company, being able to design something and produce it very efficiently.
I guess so, with the timescales that you've got.
The timescales are just
really need to be on it.
horrendous. You have to be able to design things efficiently and then produce them very quickly. There's no point having long processes in between the CAD and the production side. It has to be a very quick flowing process.
Excellent. Okay. Cool stuff. Well, thanks for that, James. Yes. And it's a fantastic story to tell with Fusion 360 being used for that. Cheers. And is there another series planned for Robot Wars? Or?
Fingers crossed. They're all still talking about it, so hopefully we'll find out very soon.
Excellent. We look forward to that with pleasure. I hope the Mack does well as well with Rico.
Yeah,
that's cool. Excellent. Okay, so if we move on a little bit then, and start talking a bit more about Fusion 360 and capability before I dive in and start showing you some stuff. Fusion 360 itself, again, it's aimed as a platform really, where we've got a multiple range of tools. So as you'd expect, 3D modeling, there's full range in there, parts, assemblies, mechanisms, all that good stuff. 2D drawings, so outputting 2D manufacturing drawings, although I have to say these days that it's becoming less and less prominent with a lot of manufacturers. Certainly people, as James has just explained, who need to get things done quickly, who certainly manufacture in-house, that need of a 2D drawing to communicate something seems to be becoming less and less of a thing. Going direct from art to part, if you like, as it's known, with our 3D model, sending it to a machine tool or producing machine code inside of Fusion and then sending it directly to a machine tool to be manufactured is becoming more prominent. So drawings are there, we can do drawings, but it's becoming less prevalent. As I said before, probably one of the biggest things is being able to collaborate on projects. So if we take Robot Wars and Robo Challenge as an example, James just shared his project folder with me, As soon as he did that, I got an email to say it had been shared. I clicked on the link, and then I got access to that folder that he'd shared with me. And from there, I could look at the data. I made a copy of the data only within his folder, so he still got control of it. But I made a copy so that any changes or tweaks that I did for this webinar didn't affect his real design. And that's, I could only do that because James had allowed me the permission to do it. But that's a massive, massive thing, particularly with people who need to be reactive and agile, particularly across geographic locations, as some of the companies we're talking to at the moment have expressed. Being able to have different people working on that data seamlessly is a huge thing. And one of the benefits with that is that because it's cloud-based, everything's just there in the cloud. Simulation as well. Again, James talked about it a little bit during his explanations of the work he's been doing. But being able to simulate parts, and that kind of covers two areas. So in the box that you see on the screen there, we're talking about finite element analysis. So placing some constraints onto a part, applying a load, and seeing whether it's fit for purpose or not. So that's one way of simulating. It might be thermal induction or thermal stress, which we can look at inside of the software as well. Or it might just be the simple case, as James said, with Dead Metal's SAW mechanism, actually understanding whether that mechanism is going to work in the right way. So we can simulate all of that within the product. Also, being able to produce CAM data, so computer-aided manufacture. So this is about when you've designed your 3D model as a part, then being able to take that part and actually machine it, put some machining to it, and then export some machine code for a machine tool to actually go and manufacture it. That's built in within Fusion now with 2.5 and 3-axis machining. As the year goes on, we're getting some more enhancements to that area as well, where we're going to start looking at 5-axis machining. So that's all inside of the product, which is quite a big thing. I recently went to a makerspace in Manchester, had a word with a few guys there, and that was one of the areas that they were really interested in to start looking at Fusion, was for the CAM side of it. So they could start understanding what they could do with that, and then maybe start feeding that out to all manner of different devices. 3D printing as well. 3D printing is not new now. I wouldn't say it's affordable for everyone, but it's certainly far more affordable than it used to be. If you look around on the web, there's a massive amount of 3D printed objects. Certainly for like jewellery manufacturers and people like those in that particular space, 3D printing has become a massive thing. Novelty items as well. Fusion 360 allows us to model in organic ways, so not just prismatic 3D modelling, as you'll see when I look in the software, but being able to take that out and actually put it on a print table and then understand, if there's any issues with that, and then feed it out to a printer to produce a 3D print is quite key, and that's part of the software as well. And then last but not least, and by no means before I get into this is not an exhaustive list of what Fusion can do, it's just tailored to suit an introduction for today. But last but not least is rendering environment. Now, my interest outside of work is photography. That's my passion in life. I do a lot with photography and creating images quite often. So I also do a lot of rendering within product as well. Fusion 360 is one of the easiest and quickest, most efficient rendering products I've used. To be able to get something very quick that looks very good. I don't think there's another product out there, to be quite frank. A few clicks and you've got something really good. And we'll have a look at that with, we'll have a look at Mack actually, that James has supplied to us later on. So as a brief overview of what Fusion, or capabilities of Fusion 360, that's roughly speaking what it can do. There's more besides, but for what we're going to look at today, that forms the basis of what we're going to get into. So, I guess it's my turn to do something. Just go and have a look at some software. So, let's just see if there's any questions popped up in the chat column. Doesn't seem to be. No, that's all good. So, everyone's quiet. Hopefully everyone's infused and absolutely riveted by what we're going through. So, Fusion 360 itself then. This is what it looks like. We just hide the data panel over there. So it's It's like sort of most Windows packages that you would see on a PC. But don't forget this will work on a Mac as well. So it looks very, very similar, but just with a Mac flavour. So it'll do both. I've got a 3D model open at the moment just so we can dance around the interface and understand how it works. But one of the key things with Fusion is its ease of use and how refreshing it is to use. I've used a number of different CAD products over the years. This is a similar flavour but with a refreshing change. It's more intuitive, it's more graphical. You can see as I hover over different commands and tools, it displays tooltips as you'd expect, and it'll also give you a graphic as well. So it's it's been descriptive on what those tools are. It's massively beneficial when you first start using the software. It doesn't take the place of training or something like that, but the idea is that it coaches you along. Okay. One thing that I did say with Fusion is that one of the key things is cloud-based. So if I open what we call our data panel here, and just go to the root of that data panel, here are all my projects that are open to me. Now that can be projects that I've created, and you can see there's a few in there, or it can be projects that have been shared to me. So I have one here with a little head symbol, and that's the one that James shared to me from Robo Challenge. So all he's done is gone into his Fusion 360, he's gone into a project. So if I was to do it on here, go into the hedge trimmer project, then I can go and invite people just by typing an email address in and invite. Okay, there's somewhat different options around what you can enable people to do in there, but that allows us to collaborate that data, open it up to other people, and obviously you've got control on what they can do. That's a massive thing for sharing designs and collaborating on that work. As James said, with having more than one person in a design team, being able to share that data and work on things quickly and effectively is key. Not only that, as we start working on the design, and I don't know whether I've got something I can show actually, probably not, but as we start working on any of the designs in here, as we save those designs, it automatically saves it back to this location. Bearing in mind that this location is actually on the cloud. It also keeps a version history. So every time I save it away or shut Fusion down, it will record that version for me. You can disable that, but generally it means that you've got a full version history of what you've done on that product as a design, which means it's very easy to roll back and look at different iterations. I don't know whether I've got any... So no. Haven't got any design history with this because it's just a straight import, but if there was, we'd see that history in there. We'd understand who had actually done it. Okay, so that's one of the key things about Fusion. That's all held within this area that we call the data panel. We close that down a little bit. So other things about the software. Well, we've got this list over on the left hand side here is what we call a browser, and what that means is that as we do things, as we generate things, typically geometry, or it might be 2D, what we call 2D sketches, so maybe a line diagram of something, how we want something to work as a concept, we can turn those things on and off. So particularly if I come in here and start getting rid of some of, if I can find it, there we go, getting rid of some of the different components. So I've removed half of the case in there so we can see inside of this. Okay, so it gives us a full breakdown of what's been done over time. Or what our design holds more accurately. Down at the bottom we have a timeline. This timeline displays what the operations that have been done to create all of this information, and I'll come back to that a little bit later on. So that's one thing. To navigate and move around the 3D environment, particularly for anybody that's not used 3D before, is very easy. We've got a range of standard tools here, so we can simply just spin the model around very quickly and easily. We can pan and just move around, zoom in and out, so it's very easy to get on with. But more than that, if we find ourselves lost or if something's disappeared off the screen, we have a view cube up at the top right here, and this view cube is standard across all of the Autodesk products in our portfolio, and it just allows us to manipulate that view very quickly and easily so that we can work with the design effectively. Okay, so that's a little bit about the Fusion interface. What I'm going to do is I'm going to create something from scratch, and I'm just going to go into relevant project. All this means is that anything I create will be saved inside of this project area. And if we get rid of that again, I'm going to say create a new design, and that's what I start with. And to actually do something, we literally, well, we don't have to, but we generally work from left to right on our toolbar across this way. So I've got a range of tools here, so I'm going to create a sketch. As I create a sketch is like a 2D plane. It's like a sheet of drawing paper. So in this case, I'm just going to choose to sketch on that face there. As I do so, we can now see we've got an orthographic view. I can move along to the next icon, or maybe pull down the full tool set and say, well, what do I want to draw now? In this case, I'm going to draw a circle. I'm going to snap that circle to that point there. I'm going to drag out, and I'm going to say 132 millimeters. I'm working in millimeters as units. I could change that if needs be. If you need to work in feet and inches, well, not many people do these days over here, unless you're across the pond over the other side of the water. But anyway, so I've created a circle, given it a dimension, so it's now fixed in size. Once I've done that, I'll finish my sketch. I just switch to an isometric view, so you can see like a disc. And if I move along a little bit to my next icon, I can see I've got an extrude command. What this enables me to do is extrude that disc as a solid. Now what's particularly useful here is I can do it, I can do it as a freeform sort of size, and just, if I'm concepting, drag some ideas down, I can do that very quickly and easily. Or in this case, I want to be specific and say 4 millimeters. I'm going to drop that down. I'm going to start speeding up as well, just to get through more content, but hopefully you'll be able to see that the menu system, rather than going to the toolbar, I've also got a right-click menu on what we call a marking menu. So I can create a sketch on there. I can hit a keyboard shortcut for C for circle, do exactly the same thing here, and in this case I'm going to say, I don't know, 120 mil, and then I'm going to choose to offset. I zoom in a little bit here, so you'll see what I'm generating in a moment, but I'm going to offset by, I don't know, -3 millimeters, and it gives me that shape there. If I finish that sketch off, just go back to our isometric view, use the same command again, and I'm going to pull that out, and let's say 20 mil. This is actually something that I designed last week. It's actually a lens cap for a telescope. I actually 3D printed this out. It took me 10 minutes to design, probably 50 minutes to actually print it, so it took me around an hour to produce one of these because I'd lost one. So that's what the idea of this is, but it's a nice introduction to Fusion itself. So straight away I've got, if I spin that model round and look at it from a different angle, you'll see that I've got like a top hat sort of type thing, or it's a cap. I can add more detail and feature onto that, so in this case if I click on this edge here, I want to add a fillet to that. Drag the arrow. I can be as freeform as I want, so, or I can be specific. Let's keep it all rounded, so 6 mil fillet on there, so it just looks a bit nicer. And because this fits over something, I want to add a chamfer onto it. So again, I could go to the toolbar at the top, but as we start running with Fusion, you'll see that all the tools that you need are pretty much on the right-click menu. So in this case, I'm going to say I want a 2 mil chamfer that allows me to slide this over the end of the lens or the optics that it's protecting. Okay, and that pretty much done is a very simplistic design. I can go a little bit further with that, and I can create a component from it. So I can also change its physical material. So if we said it's going to be made out of plastic, ABS, I drag that plastic on there. Now the material quality is now ABS plastic, and the colours change to suit. I can make a component based on that. What that means is it's now a component in my browser, so I could go and name that, so on and so forth. And last but not least, if I save this, it's going to save it to my Fusion webinar generic area, and I'm going to call it lens cap demo, and it'll save that away. And that's the basics of 3D modeling done. Okay. What if we wanted to produce a drawing of that? As you'd expect, we go new drawing from this design. Again, it's very descriptive on what we're doing, and it just allows us to generate a drawing based on this design. We've got some options here on what size of drawing sheet we want, typically. what the units are. We'll leave all that as default for the size that we've got. What it allows us to do is then just start placing views down inside of that drawing. But those views are based on the cap that we've just designed. So if I drop this view here and just change it so that it's 1:1 in scale, he says. There we go. Okay, that, and now I've got a view there that I can move around, reposition to wherever I want, and then I can create subsequent views from that. So in this case, I'm going to drag a view over this side. I've now got a projected view, as we call it. If I wanted a sectional view, I can do that as well. So in here, I'm simply going to draw a section line through there and place that section view over here. The difference is that because it's sectioned through this where the AA section line is, we can see now the inside of that. So it's only very basic drawing, but it gives you some idea of the fact that we can generate 2D documentation based on our 3D model. We can obviously add dimensions to that from manufacturing information. So if I wanted to add different dimensions onto here, I could do so. And the beauty is that those dimensions are associated with the design. So if the design did change, those dimensions would automatically update. Also, the beauty of this is that we can output. So this is a Fusion 360 drawing, but for anybody that's come from the traditional CAD world, we can export out to an AutoCAD DWG file. For most people who are coming into the CAD world from new, if you like, outputting as a PDF file is probably one of the key things that they'll look to do. So I select on my desktop here, give it a name, I can generate that as a PDF file. If I just minimize Fusion and get rid of my PowerPoint for a moment and find where our PDF is, there's the PDF file that you could obviously send out to somebody to manufacture if that's what you needed to do. So that's our 2D drawing environment covered, or the ability to generate 2D documentation. We typically save that. We'll save that there as our drawing. So that's great. That's prismatic shapes, if you like, but just looking at time, we're cracking on a little bit. So what about if we wanted to produce something more organically shaped? So this is a Fusion logo as a keyring that I have on my laptop bag, actually. I've just been showing to James. This was actually printed out of copper or copper infill on a standard 3D printer with a copper material, which is quite cool. But we designed this inside of Fusion using a mix of standard 3D modeling techniques, but also surfacing as well. And it allows me to just talk a little bit about what we call workspaces within Fusion. So we have a standard modeling environment, which allows me to do the things I've just shown you with the lens cap. I also have a patch environment where I can start doing surface modeling and create patches and create more organic shapes. I've got some other areas as well that we'll cover on in a moment when we come back to it with some of the other. There we go. With some of the other models that I've got to show. But if we come to here and we look at this shape here, so this is just like kind of a rough idea of a ring that I designed last night using Fusion. Now to do that as a surface model would be an absolute nightmare. Well, the way we've done this is using our freeform environment, so our sculpted environment. So what this enables me to do is modify. Go back to our body rather. It allows me to modify the shape that we've got in there. So if I come into here, it allows me to, I'll tell you what, let's just create a new one rather than tinkering about with that. So if I come in and say I want to create a torus shape, I'm going to drop one on there, about there, and then I can't remember what size it was, about 18 mil, something like that. I've now got this sort of a shape. Okay, I can change the size of this, I can change the fatness of it, so on and so forth. But the point is that I'm not doing this traditionally. I'm doing it inside of a very easy to use, very simplistic environment. In so much as if I put some symmetry in there and then start coming in and deciding to actually modify this very quickly and easily, I'm not going to go through a full design because I don't have the time, but hopefully you'll get some idea of how quick and easy it is to start creating far more organic shapes. And it touches on what James talked about before with Matilda's spikes, being able to quickly modify what you've got there and push and pull and tweak things around to produce a kind of a weird and funky shape is very, very easy to do in Fusion. And it's one of the reasons why Fusion is used quite wide-rangingly in jewellery manufacture and people who are doing that type of work. Okay, it's another one of the areas that we have within the product. So if we took this, in fact, let's go back to the ring actually, because the ring's a bit more interesting. If we took this shape and I wanted to manufacture this, okay, typically you'd 3D print this just because of the shape that it is. So I did say we've got a print studio in there that allows us to come in, look at the geometry. This is basically creating an STL file, which is what 3D printing understands. We can tweak that and how that works and the resolution of that STL file. But if we then tell it to take it into Print Studio, based on the options we've got set, within there. So I've got this set as using an Ultimaker 2 printer at the moment. Its material is 3mm PLA. We've got some settings in there. I'm now just looking at the object as it is. Now, as it's come in, it's typically not going to print that way round. So I can reorientate that quite easily. I can tell it to auto lay that out and it'll look at things and try and decide where best to place it. I can lay it flat. When I lay it flat, these little blue areas are basically flats that I can specify for it to sit on the table. So in that case, that's the orientation that I want. But if I move this around a little bit, you'll probably see that there's some issues underneath. Anybody that's done any 3D printing will see that there's an overhang there, so we've got a problem. Fusion 360 allows us to start looking at that on Print Studio. So if we repair the geometry, there's no problems with this in this case. If we then look at supports, I can say add support. It'll automatically add those supports for me. I can go in and manually create supports as well. I can add additional supports if needs be, but the software will give me a solution. And then from there, I can preview the print before sending it to the printer. I don't have a printer rigged up today, so I can't actually send it to the printer. But in here, you can see it's now looking at the toolpath for that printer, and it's generating some preview for me. So I can now understand how the thing would actually print on the table, and I can slice through that and understand how it's going to print that as we go. Printing the supports first, obviously, and touching on the edges of the ring that are touching the build plate, and then up through the model. So that's another part of Fusion 360 that's in there with Print Studio. So, get back to Fusion. Okay. So that's kind of touched on parts and just standard parts and such like. What I want to touch on now is assemblies and mechanisms. So this is part of Dead Metal. Thank you very much, James, for lending us this. This is the real design data that we've got in here. And the first thing I'm going to do is just talk a little bit about assembling things. So in this case, I'm going to use what we call joints to fix things together. So in this case, I'm going to say this item here needs to fix to this item here. Tell it to go away and do that. And then we've got the same thing here, where we need another joint on that surface there to this surface here, or this edge rather. And the reason for doing that is, now I've added that in, if I go and grab this piston or this ram at the back, and I can now see the jaw was talking about, the jaw that James was talking about for Dead Metal, and how that movement's working. Okay, so we can assemble things together, multiple parts. Probably more importantly for this vicious approach that James has about designing his robots, this mechanism of the friction saw that's on Dead Metal. This is what James was talking about, where it kind of lifts up, comes out, and then digs in. I'm right in saying, yeah.
Looks great when you see it moving like that, doesn't it?
It does, yeah. But that's again, being able to do that inside of this virtual environment is massive. It's a massive benefit to understand whether something's going to work or not, or whether it's giving you the desired effect. Okay. So that's a little bit about assemblies and bringing collections of parts together. Moving on, so what we're going to look at next is maybe have a look at some of the simulation side of things, if I can find it. So here we have, just for simplicity, a plastic component. It's actually the trigger off a hedge trimmer that's designed in Fusion. And what we want to understand is how this is actually going to work. So in this case, I want to do a design study on this and actually understand whether it's fit for purpose. So you can see inside of the standard product we've got static stress. We can look at harmonic frequencies with modal analysis. We've got thermal and thermal stress. That's all in the standard product. They're available to us. For what I'm doing here, I'm just going to choose a static analysis. I'm going to come in and choose what material. He says I'm going to choose what material. Thank you. GoToMeeting is playing about with my screen today, unfortunately, so I'm not getting the appearance, but ABS plastic is what it's made from. And then from there, I'm simply going to say I want some different types of constraints on here. So I want a pin constraint, typically where this fits within the model. And it just means that that's fixed there. It also acts on a portion of the internals of the saw, and that's basically how that's fixed together. But I also need to put a load onto here. So this is where your finger would typically press. Just to get some results, we'll put 100 newtons on there. Once I've done that, I can now get the software to go away and analyse that for me. And then based on that simulation and those load conditions, taking into account for the material, I can see actually what's going to happen. So in here, I'm looking at safety factor at the minute. I can tweak the scale, how that's actually appeared, look at different areas. I can do a lot within this environment. Just for time today, we'll just animate that quickly and show you what's actually going on. So hopefully you can see that on the screen. You can see that it's bending, and as the colours change, we're seeing where we're getting the raised stress within there. Okay, so that's all within the standard product, and hopefully that's something you're going to start using.
It's really interesting seeing it for the first time, just clicking and seeing the actual stress patterns on there. It's really cool.
It's a really intuitive way to work, very easy to get on with as well. Okay, so that's simulation covered. I'm just looking at time. We're not at the end, but we're getting towards the end. So just want to pick up a little bit and go into the CAM environment. Now, all the time that I've been doing this, I'm using this workspace area here that allows me to flick into the different areas of the software. They're all inside of the software, but they're just different toolbars, effectively. So inside of here, what I've got is a component that's going to be machined. Now, I've got something pre-set up just to show you working. So if I speed this up, we've got a milling tool that faces off our material. I've then got a different tool that goes around and mills the profile out. So it's basically contouring around there. And just to finish this off, I want to pocket out those portions inside. So just to show you how easy this is to do, I'm simply going to go in and say I want to produce a 2D pocket. And then once I've done that, I need to select a tool. So I could use a tool there, but it's a bit big for my purpose. So I'm going to go with a 6mm diameter milling tool. If I just move this window over here so you can see. Feeds and speeds are in our tool catalogue, so they're already defined, or you can tweak them accordingly if you've got some preferences that you want to use. And inside of here then, all I'm going to do is select the geometry that I'm interested in, which is basically these two pockets, and that's all I need to do. If I now simulate that and show you what it's actually done, we click play, there we go. We can see now that it's going to run through, speed it up a little bit, it's now running through those two pockets. Now I'm just looking at that one machining operation that I've done, so it's not including the rest of the information, but that's already there, as you can see in this list. Okay, so really we've got a really good CAM solution embedded with inside of Fusion 360. 2.5 and 3 axis machining is there at the moment, and then later on this year we're going to be looking at 5 axis as well. And then really to end off, we always end with a kind of a flurry, and if I can find the right thing to look at, yeah. We're going to look at this model of Mack, the actual, or Record dog.
Mack from Record.
What's it called? The Dogbot or something like that?
Corebot, I think.
Corebot.
Its actual description is, but cool.
Okay. Well, again, thanks to James for sort of opening this data up to us. But this is like the modelling data that you can see on there with some imported geometry for the
yes.
for the body as well.
So
yeah.
You can see the body stuff there in the light purple. That's direct from the game data that Xbox sent us, and then we've created all the internals and all the skeleton, the legs, and making sure
Everything
it all
else
moves.
to actually make it work.
Yep.
Fantastic. So it's a combination of two sets of data really coming from Microsoft. And,
exactly.
Yeah. Brilliant. So that's the design environment. But if we switch into what we call the render environment, when it appears, so this is normally instantaneous. It's just that we're recording the webinar today with GoToMeeting, so it's playing with my screen, which is useful. Come on. It'll get there in a minute. So basically what we're going to do is go into like a visualization environment, hopefully. Come. It's not going to play with me. Not going to play. Okay, it is a live demo, folks, just to prove that it isn't videoed. Love it. Okay, well, while that's thinking about maybe coming up, just to show you, these were basically done with Fusion 360. This literally took about 2 minutes to set up. So the background is one of the ones that ships with Fusion 360, but you can put your own in there. There's a 360 background, or you can have a more like studio environment. And you can see that there's some reflection on the lights from the materials that James has put onto the like the main part of the dog body there, reflecting around. So let's see if this is going to play for me. It's not, is it? Okay. Well, what I'll do is I'll record a little bit of video of that working, and I'll get it posted up to join the webinar itself. Apologies for that. I don't know why that's not playing today, but yeah, it's not going to work for me. No, best laid plans and all. I assure you, if you have a look at Fusion yourself and have a play about with it, that'll just pop up. Just go into the render environment. You've got a whole range of tools that you can play about with in there. To set things up as you want. So going back to our PowerPoint, just to finish off then. One of the other key things with Fusion, I'll give you a web link at the end of this just to go and explore, but one of the something that's kind of unheard of really with all the vendors out there really is actually having a roadmap of what's being developed within Fusion. So if you see here, this is a screen grab of the live Fusion roadmap website, which anybody can go to, and this is giving you a roadmap of what's being developed and some idea of timescales on when they'll be delivered rather within the product, where they're up to and such like. It's quite unheard of within the CAD industry, and for people looking for different things, and obviously the ability to feed into the system of what you'd like to see as well via Idea Station, that's normal. But being able to see what's coming up on the horizon is quite useful. So, only really remains for me to just put that link on screen there. If anybody's interested, just autodesk.com/fusion or do a Google search for Fusion 360 should take you to the Fusion 360 landing page. From there you'll be able to find out everything you need to know. You'll be able to download the product for free as an evaluation and a trial. There's a whole host of recordings and videos on there that you can learn more about the product, or indeed actually use it as training if you like, and actually get to know the product a little bit better. I'm just going to have a look on here to see if there's any questions, which there aren't. Okay, somebody's said menus in there. I'm not quite sure what you mean by menus, but so yeah, this area here, what we call workspaces, is the different menus. The menus themselves are listed here under the icons, so different tools are all available under there. Okay, or quite a lot as you're working within Fusion are on the right click menu, so it allows you to do what you need to do depending on where you are at that point in time. So all it remains for me to say is a massive thanks to James for coming along today and sitting in and talking a little bit about the cool work that he does and his company. Also for sharing some of the data with us. So thanks very much for that. And thank you guys for attending the webinar. Hopefully you found it useful. If there are any questions, there are feedback links on the invites. Please feed them back to us. Myself and the other guys will... Oh, we have got some late questions coming in. Bear with me. I can see it. So, sorry, late. Why is this? So, can you do stress simulation on wood? So, wood is a non-linear material. So, right now, as of today, no. What you can do as an approximation is do a range of static tests across different properties of the wood that will give you some idea around where that will fit. That said, later in the year, for anybody who's into stress analysis, we should be having the inclusion of a Nastran solver in there, which will allow us to simulate non-linear materials. So there will be a solution towards the back end of the year. Oak or pine, yeah, so any wood really. Will you be sending a link to a recording of this webinar? Yes, we will. So Katie's going to sort that out. Wood question, yeah. How did you get the Xbox model parts in Fusion? Well, how did you do that, James?
It was pretty simple, really. They just sent us the STLs, and as you saw in the menu there was a feature for uploading your own sort of documents, whether STLs or STEP or IGES files. Just uploaded them and then inserted them into the design. So we started playing around with making the skeleton, and then we just inserted into current design.
Perfect. Okay. So yeah, absolutely. Well, yeah, I couldn't have said it better myself. And a real life example of how you're working. Okay, folks. There's a few thanks in there. So again, thanks for your time. Thanks for attending. Reach out if there's any questions or if you want to know more. Thanks for attending. Cheers. Okay, folks. So this is the addition to the webinar recording from early this morning. Apologies for my slight technical hitch. As you can see here, within Fusion we have our workspaces, so modeling, surfacing or patching, render environment that we'll look at shortly, animation where we can explode things and do like technical illustration, a simulation environment as shown, and also the CAM environment as shown. So for this we were talking about looking at Mack, the Xbox dog. I'm going to flick into that render environment, which brings me in here. So straight away you can see that things are looking a little bit more lifelike straight out of the box. This is because we have appearances and things applied to different objects within here. So different materials, as you saw me do with the standard part, the cap that I did earlier. We can apply those different materials and so on and so forth. However, what I really wanted to show you is if we get rid of that, maybe just get rid of the browser because we're not interested in that at the moment. So we've got our view. Typically when we're rendering, we're going to go into a perspective view. Because we're in perspective, we can then start playing around with the viewpoint or the lens properties. So at the moment, if we look at Mack there, he's sat or stood. Fairly straightforward, but if I start to change the focal length of the lens, you can see how his head becomes more pronounced. We're also seeing a basic shadow based on the lighting environment that we've got, which is the standard environment out of the box. So if I just close that and hit render here, what you'll see is the view get pixelated and then it'll start actually rendering the object. So you can see now that it's starting to generate an image from that. So this is rendering locally on the machine. We can also send this off to be cloud rendered as well, in which case when it's finished you'll see the renders appear down the bottom here on your gallery. But for now we'll just choose to render it locally. So that's a basic render, but straight away you can see that on the floor we've got some reflection from the glowing of the light of Mack's body. We've also got some slight blue hues from reflected surfaces as well in there, so we can see that there are some, sort of realistic properties going on. However, just to show you how easy this is to use and get something looking something like, if I go into my environment library, literally drag and drop that environment in there, and then tell it to use that environment as the background, now we've got that environment as our backdrop. Now if I position Mack something like so, maybe just make the lens a little bit more wide angle so we've got more pronunciation. I'm trying to get a certain look and feel with this, and actually that's about right. So I want Mack about there, something like that. I can move and rotate the environment, so you can see there I can shift the sun around, so if I wanted him in the sunlight I could do that by dropping that round there. As it is, I want the sun behind his head, so it's emphasising his head even though he's in shadow. We can still change the exposure values in here and tweak things, and I also want to put some depth of field. So what this is about is generating a point of focus just as you would do with a real camera. So I'm going to drop his eye on there, although he's not looking at me, but that'll be fine. And if I actually leave the blur there, and if I now render that, we're going to see the same thing happen before, but this time, because we've got a realistic environment in the background, and because we've turned on depth of field, very, very quickly and easily I can get something that looks pretty damn good. Now I need to leave this a few minutes to render out properly as the photograph that I showed you before, but in this case straight away you can see that his head's nice and sharp. We've got all the shadow going on, but the back of the body is nice and blurred. That's what we call depth of field. The point is that all those features are available right in the software. We can very easily do it, and it really is one of the best rendering products that I've found to do simple renders to get something done very, very quickly and effectively. And that was really what I was trying to show you before. So again, apologies for the webinar and that I couldn't do that. Okay, hope you enjoy. Thanks.